Yeah, so today's workshop will be basically about RNN, Lstm, and media pipeline. And today the workshop will be relatively shorter, since yesterday's workshop already covered a lot of the key parts and details parts. So yeah, let's start. So what is RNN? RNN is basically a short form for recurrent neural network, which is a type of neural network in which the output from the previous step is fed as input to the current step. Yeah, as you can see here, the X represents the input, and the S is the what we call is hidden state, and the O is the output. So the the weight of each previous hidden state will be passed on to the next hidden state, so that the next hidden state will learn from the previous weight up, and then it will relate everything together. So move on. This is like the structure of RNN, and then this one is the structure for CNN. As you can see, the output, where for RNN the output will loop back into itself, and for CNN it will only move forward. So you might want to ask, what is the difference between RNN and CNN? So I will explain it using a scenario. So I believe most of you used Word before lah. So there's something called auto typing, where now I'm typing, hope you are in the. Then at this moment the word ping of help will start to pop up, as the algorithm behind predicts that we are going to type this word in this sentence. This is because they are using RNN as the algorithm. So when we type in this sentence, which is the word in white, so the RNN will relate the whole sentence and start to understand the meaning of the sentence. Therefore, they will predict the word that you are going to use next. Whereas with CNN, you are unable to do so. Why is it so? Because when I type hope you are until the R there, the CNN will start to forget about hope. So when I reach the sentence will be very weird. So which makes the machine unable to understand what we are trying to write. So it will not be able to predict that the next word will be the ping of help. So in this case, RNN is more suitable for handling sequential data, for example, videos, whereas CNN is more for spatial data such as images. But RNN only has short-term memories. What is short-term memories? So I will explain it with another scenario. Now I'm writing an essay. I grew up in France, and then in between blah 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 blah, a few sentences in between, and then I write I can speak fluent. If I'm a human, I'm reading this passage. Suppose the word in red, I will know that they are going to write something about a language. And since I grew up in France, so this language will be French. But RNN won't be able to predict the word is French, because in between there are a few sentences, and here we call a gap, which is, you can see here as a gap here. So due to their short-term memories properties, so they will start to forget the outputs from earlier inputs, and then we'll be unable to predict what we are trying to do. So in order to solve this problem, they come up with a variant of RNN, which is called Lstm, long short-term memory. So how does Lstm helps to solve this problem. So the core idea of LSTM is there's something called the cell state. And the cell state is like a conveyor belt. It runs straight down the entire chain with only some minor linear interactions, and it is very easy for information to just flow along it unchanged. Yeah, so this one is what we call the cell state. As you can see, is compared to the so compared to Rnn, Rnn won't have something as complicated as this, and Rnn will also don't have something like called the cell state. So this cell state, basically, it can retrieve information from the latest input, and then it will also have something called the gate to remove or forget informations that are not needed. So now I'm going to move into the hands-on part. And before we start, I would like to introduce a bit about MediaPipe. So MediaPipe is a library where there's a lot of function to it, like what what our speaker did yesterday, face detection is also one of the function of MediaPipe. And then for today, we will be using the function called holistic, which is actually the combination of MediaPipe post, hand, and then also face mesh. So there are also other similar libraries called OpenPost, but this one is more for detecting the post and then drawing a skeleton on your body. So if you're interested, you can go and play it out. Yeah. Okay. So now I move on to the hands-on part. Yeah. Oh yeah, by the way, today I will be using another tool called Jupyter Notebook. Not sure if you guys know what is a Jupyter Notebook. Yeah, so this is Jupyter Notebook. Basically, it's something like Google Colab, but unlike Google Colab is I think you can say is online. You need Wi-Fi to use it, but for Jupyter Notebook, you just need to download it, and then you can use it on your laptop without the need of internet. So after you download it, here's how you access Jupyter Notebook. So you go to the folder that you want to access, the Jupyter source file. It's called IPYNB file. This file is also accessible on Google Colab. Yeah, so go to the command prompt, and then you type here, Jupyter book. Enter. It will pop up interface from here. Then from here, you can just select the files you want to access. Like, for example, today I'm going to use sign language recognition.ipynb. So I just click it. It's as simple as that. Okay. So I'd like to show a bit how MediaPipe holistic work. So basically, first you need to import the libraries, and then before that. So if you want to use MediaPipe, you can just go to their documentation here. So just click on getting solutions. So today I'll be using holistic, right? Then just scroll down here. And then here you can see the code part. This one is like basically what you will be needing lah. Just copy and paste lah. So like now I'll be using webcam input. So I'll just from here copy and paste this part. Or if you don't want it to be this messy, you can also like what I did here. I just refer the code and then create a few functions here. Yeah. So you can see this part is this part here. Yeah, see? Image flag writable false. Oh no, not here. Oh yeah, see this part. Here. And then this is the draw for the draw landmark part. I put it here. Okay. So continue. Okay. So basically, Jupyter is just a tool that you can do all this stuff. It basically collects your coordinates of the pose on your body. Like this dot here on my finger, it will be able to tell using MediaPipe. So you can use MediaPipe for a lot of functions. Like maybe you want to do action recognition. So these key points will be like very useful for you to do. Okay, so move on. It's one data set also. For today's data set, I'm creating my own data set, which is a very small sample. It's only consisting of like 30 videos. Yeah, so if later after the workshop you are interested in like maybe play around with this code. Oh, by the way, I will send in this IPRMB file into the AI workshop later. So if you're interested, you can just create your own data set and then play around with it. So like today I'm doing sign language. So it will be, I'm doing a sign language for hello, thank you, and none. Okay, so let's move on. And then after you have prepared the data sets, so this part is also just like what Jingyip covered yesterday, pre-processing. This one here, you split it to train, test, Y train, Y test. Yeah, and then just put it into the model that you created, which in this case here, I'll be using the Lstm layers, and there's layers only. Yeah, so, and one thing, when you are trying to train your model, you would like to like see how well is your model doing. So here we can use a tool called TensorBoard. Yeah. So basically, if like I start training now, yeah, so like I start training now, and even though you can like get the accuracy and loss from here, but still you would like to like have a clearer visualization, right? So now you can use one thing called the TensorBoard, where you access it. You also like need to go here, go back to the folder, and then you find a log folder which I created to keep the the record of the training at each training. So again, open the CMD, and in the command prompt, type TensorBoard log directory. Let it run for a bit. Okay. As you can see here, there's a URL link. Copy this and paste it at the place at your Google. Oh, wow. Okay. Yeah, so this is basically a graph, but I'm not sure why it's so messy. Okay. Yeah, so basically, it will look like something like this. So what you train, you'll be able to, for each training, you'll be able to look it from here. And then from the graph itself, you can like observe which epoch you would like to stop, or maybe why is it that there are so many spikes and stuff like. So from this visualization will be easier for you to decide whether what hyperparameters you would like to fine tune to get a better results. Okay, so back to here. Yeah, it's already trained. And run this code. Here. And then finally, this one is also like a function for later. I will like output some words on the frame. And then this one is, yeah, so basically we will use the model created here and put it in here. Yeah, here. Model.predict. Use it to predict the sequence, the webcam input later. So I'll just run this code now. So yeah, maybe something like this. Hello. Yep. Yeah. So that's basically all there is to it for today. Yeah, so that's all. So basically today's workshop will be more like a brief introduction to RNN and LSTM, so that you guys would, if you guys are interested, you can go and do some research on it stuff. So yeah, I think that's all from me today.